Hi everyone, and welcome to the Future of Urban AI webinar series. It's a great pleasure of welcoming you today for this second episode of season 3 of this webinar series. My name is Hubert, I'm the founder of Urban AI, and I will be your host today. For this second episode, we have the great pleasure of welcoming 3 amazing international experts to explore how AI can be used for sustainable cities. And to explore this topic, we will first have a presentation from Tanya Tsui, who is postdoctoral research fellow at the MIT Sensible City Lab, and will present how AI can be used to create more circular cities. Then Ruth Nelson, who is special data scientist at TU Delft, will unveil how AI can be used to create inclusive cities. And lastly, Josefine Hintz, who is doctoral researcher at the Mercator Research Institute on Global Commons and Climate Change, will present how AI can be used for low-carbon cities. Just before jumping into this second episode, a few words about the Future of Urban AI series. This is now the third season dedicated to exploring the future of urban artificial intelligence. It's an ongoing collaboration between Cornell Tech, who is represented today with Anthony Townsend, and with Urban AI. For the third season, we will have 8 episodes. So that is currently the second one. And in incoming episodes in the following week, we will explore many other different fascinating topics as this one today. Previous episodes of season 1, season 2, and actually already season 3 are available on Urban AI YouTube channel. And the report of season 2 is available on this link you can see on the screen, and that we will share in comments during the episode. Lastly, you can go on the futureurbanai.org, which is an ongoing project led by Cornell Tech, which is mapping actually different use of artificial intelligence for climate adaptation. We will also share it in comments, and it's definitely related to the topic of today. Thanks again for being here. Ruth, Tanya, and Josephine, the floor is all yours.
Hi, everyone. I'm going to be starting the presentation. Then I'll be followed, I think, by Ruth and then by Josephine. So let me just share my screen. Okay, shout if you cannot see my screen. Yeah, my name's Tanya, and today I'll be talking about visual AI for urban sustainability. I'm a postdoctoral fellow from MIT Sensible City Lab and at AMS Institute in Amsterdam. I did a PhD in TU Delft on spatial approaches to a circular economy. So in short, my research is about circular economy, data, and cities. But today I'm going to talk a bit broader than circular economy and present some of the work that is happening at the research lab that I'm currently in, specifically on AI and sustainable cities. So the lab I'm in, Sensible City Lab, we're focused on these 4 numbers. Cities occupy 3% of the land, 55% of the global population, and cities also consume 70% of global energy consumption and produce almost 80% of all CO2 emissions. So if there's anything that we can do about sustainability, cities are probably not a bad place to start. So the first step to making sustainable cities is to monitor its current conditions, what's happening in the cities now. These conditions can be things like temperature, air pollution, energy use, material use, all of these things. And so, for example, here we can see locations in Amsterdam where air quality is being measured by different types of sensors. It doesn't look so bad, right? There's around maybe 30 to 50 stations all over one city. That looks pretty good, right? But unfortunately, in our opinion, that's not enough because conditions can vary in different parts of the city. They can vary a lot. So even 2 streets in the same neighborhood can have hugely different conditions depending on what's on the street, right? So in the picture you see here, 2 streets in the same neighborhood can have a huge temperature difference because of the presence of trees, right? So the issue here is how can we get data that's detailed enough to capture these differences between different locations, right? We could hypothetically put a sensor on every single street in Amsterdam, but that does not make sense for many reasons. It would be expensive, labor intensive, use a lot of materials. So that just wouldn't make sense. So the question we have is, how can we get urban data, specifically data related to sustainability in our case, that is high resolution and cheap? When I say high resolution, I mean high spatial resolution, right? So instead of having one number for the temperature of Amsterdam, we have 1,000 numbers for every street in Amsterdam, the temperature of every street in Amsterdam, for example. And when I say cheap, I mean we don't need to put a sensor in every single street in Amsterdam, right? So high resolution and cheap is the goal here. And one potential method we're exploring to answer this question is to use computer vision. We currently have a lot of eyes on the street, right? We have street view images, footage from cars, security cameras. And from these images or videos, we can capture a lot of what's happening in the street in real time. So we can count how many cars there are. If it's a video, we know how fast they're driving, the predominant materials that are on the street, how many trees there are, how exposed the street is to the sky, so many things. So an image or a video is a very rich source of data. So using this as a source, I'll showcase 3 projects of the research group that use these techniques for specifically sustainability in cities. So the first project is called Treepedia. And the project measures the presence of trees in cities, and this is important because trees provide all kinds of services to cities. And the key is to quantify, numerically the amount of green that's along streets, and be able to compare streets and cities. The method is basically taking street view images and counting how many green pixels there are in each image as a measure of how much green there is on the street. And using the images, that allows for a very high spatial resolution, so you can have multiple points on the street. You can have data for all the streets in an entire city. And right now the team this is actually quite an old video, so there are probably even more cities than are shown here. So basically the idea is to be able to compare the tree coverage for different cities in the world. Next. So the handy thing about using Street View is that we no longer have to rely on governments for spatial data, right? For example, there are some governments like Amsterdam that have very good data on trees, their location, their size, their species, but most cities don't have the resources or the time to collect this kind of data. And so in the past, we weren't able to do this kind of analysis for those cities. But then if you use Street View data, there's a much larger coverage, a global coverage. So then we're able to analyze and compare, for example, tree data for many more cities. The second project is called AI emissions. And so in this project, the team looked at using computer vision to monitor emissions in the city caused by traffic. So they used video footage of roads in Amsterdam and then detected on each location which cars, so the brand and the model of the car was driving on the road and how fast they're driving as well. And so once you know the car, brand, and model, you can link this information to the emissions values of these specific car brands, and then estimate the amount of emissions that are emitted at that specific location. So the results, here's some first results. So this is, data collected from a car driving around Amsterdam, footage of a car. And so this potentially allows us to monitor traffic emissions at a higher spatial resolution. And if there are enough cars and enough footage, then it could be even have a high temporal resolution, right? So looking at things in real time. So it could be that, we could use video footage from cars, but also, put cameras onto public transport like trams and buses to be able to constantly monitor the air pollution on the roads in the city. And the final project is called B++. And it focuses on these four numbers. So approximately 20% of all vertebrate species are at risk of extinction in the wild. 41% of ecosystems are at the brink of collapse, and another 65% of insect species are at risk of detection due to climate change, and there's been a 69% species diversity decline since 1970. So this project uses computer vision to monitor insect species diversity. And it can be used as a proxy for diversity. So the idea is you can set up a camera and then be able to detect, the insects flying in the screen to see what kind of insect it is. So it uses an existing repository. Give me a sec. Of 2 million insect images. And the model can detect around 2,000 insect species. So the model has already been published. It's open source, so anyone can use it. And currently the team is working with the city of Amsterdam to deploy something called Sensing Gardens. Probably this name will change, where a camera will be set up, and then there'll be some kind of thing that attracts insects, whether it's like some flowers or some water or something like that. And then so that, those specific locations can be used to monitor biodiversity in a city. So those were the three projects. If you have any questions, I'm happy to. We should probably leave questions at the end, I suppose, but feel free to also email me if you have any questions about the project.
Great. So I think we'll move on to me. Let me just share my screen. Perfect. You can hopefully see the slideshow. Yeah, great. Awesome. Okay, so the title of my bit of the presentation today is AI for Transportation Justice. My name is Ruth Nelson, and I am a PhD researcher currently at TU Delft at the Center for Urban Science and Policy. And my research focuses on urban inequalities across a range of domains, from housing to transportation, but I also engage with things like equity and spatial justice. And the project that I'm going to present today is very much based on a lot of the research that I have been doing over the last 3 years. It was actually the center of my wonderful student, Krista Brain's thesis, which was entitled A Reinforcement Learning Approach to Equity in Multimodal Transportation Networks. And he was supervised by myself, Dr. Trivik Verma, and Young Kwakkel. So this is one case which is going to demonstrate this theme of AI for transportation justice. So within research, there's been growing concern over the equity impacts of public transport investments, particularly in relation to accessibility of social and economic opportunities, which of course are very much linked to issues of social inclusion. Within practice, however, equity is not typically formally sort of considered within transportation sort of appraisals, right? It might be a normative consideration, but it's not linked to any sort of specific definition of equity. Transportation networks are generally optimized for things like profit making, reducing cost, for some aspect of their operational functioning. Of course, optimization is very much a typical sort of engineering problem, and we don't usually think of equity in this way. This is also because transportation networks are complex. As they grow and they change over time, accessibility and equity changes. So really, this project, what it aimed to do is to kind of marry ideas from optimization with equity, and to address the problem through using a reinforcement learning technique, which I'll get into a bit later in the presentation. But essentially the question that we asked is, how can we generate transportation networks or optimize transportation networks based on different notions of fairness, equity, using AI? So a brief background, there's some things that we need to kind of clear up before I get into the details of the project. Firstly, on accessibility. So just to demonstrate what accessibility means, an individual lives in a specific place. There's a certain area that that individual can travel within a reasonable period of time. There are lots of potential useful destinations that individual could reach, such as restaurants, hospitals, educational facilities, but they're limited by that time that they can travel in, you know, and that depends on the transportation networks they have available to them, money in their pockets, whether or not they can walk, maybe they're disabled. In this study, we particularly focus on accessibility to jobs. So what is equity of access? Well, equity of access is really concerned with the fairness of the distribution of accessibility. And you can use, you know, specific notions of justice to understand and to define fairness, right? And obviously your definition of fairness is very much linked to how you view fairness, and you can compare and contrast and reveal trade-offs by using different definitions. Now, we are researchers, we're not philosophers, so we haven't sort of imposed any value, but what our aim is to do in this study is to reveal the impact on accessibility when we evaluate it from different notions of fairness. And then basically what we aim to do is optimize the distribution of accessibility with the transportation network based on different notions. So what we do is we draw on social welfare frameworks, which are from economics. And essentially what they do is they allow us to evaluate the distribution of access based on a specific notion of fairness. Usually they're applied, as I said, within economics, but we use it to evaluate accessibility. And we look at access, as you see in this image here, within hexagons in our case, which I'll introduce a bit later. And we use three sort of notions of fairness to evaluate these accessibility distributions. The first one is based on utilitarianism. I don't have the time to go in great deal into it, but basically what you're trying to do is maximize overall access for the system you're looking at. We also then use continuous prioritarianism. So what you're trying to do here is you're trying to maximize accessibility, but not for those who have the highest amount of access in the system already. For those who have less access, you're giving priority to those areas which are less well-serviced. And then the lowest quintile, basically, what you're trying to do is maximize access for those who fall within the lowest quintile in the system. Basically drawing on a Rawlsian idea of fairness, which aims to sort of make sure that those who are least well off in the system benefit the most. And then we apply reinforcement learning. So reinforcement learning is a machine learning technique. Basically what it does, and it allows for it, is it trains an AI agent to interact with an environment. And this AI agent sort of runs loose and it receives feedback in the form of rewards or penalties. And it's able to make a lot of different decisions in the system very quickly. And in this case, we give it rewards in terms of the amount of accessibility as well as the social welfare framework. And it tries to sort of optimize for these different distributions. So onto the method briefly, and then I'll get into the results. Essentially what we have is we have streets, we have all the transportation networks, we have jobs, right? We create a gigantic urban network model, and we're able to calculate accessibility within this. So we look at the hexagons and we say, okay, how many jobs can be reached within a certain time threshold, which we use 60 minutes. We then simplified that network because the network had many, many nodes and edges. It was very, very big. So to reduce computational time, we had to simplify it. We had our three notions of fairness, and then we had our reinforcement model, where we trained the model, and then the model allowed network expansions based on the access and the social welfare functions that it was sort of aiming to optimize for. So we used the case study of Cape Town in South Africa. Why is it a good case study? Because South Africa, according to the Gini Index, has one of the highest levels of inequality in the world. I'm also from South Africa, so I was able to get some great data from there on the transportation networks, which was necessary for the study. This is like current accessibility at 60 minutes, just to show you what it currently looks like. you've got the CBD here, if you can see my mouse, and then as you kind of leave the CBD, accessibility kind of gets worse and worse with distance, particularly here in the south east. So on to the results. So we were successfully able to generate stations, essentially, of where new transportation stations should be based on our three notions of fairness. And you can see that they're quite different locations in the city. In terms of the utilitarian results, the model basically suggested in the end that we place stations in the central northern section of Cape Town. And this is an area which is already characterized by good accessibility. So essentially, what this notion of fairness really was doing was reinforcing sort of existing accessibility patterns that exist in the city. Then we had the prioritarian approach, which focused on redistributing access to those who are less advantaged. And what it suggested is linking the central business district with areas in the center of the city here, which are characterized by less accessibility. And then with the lowest quintile, kind of obviously it really did focus on those areas which have the lowest accessibility in the city, and this is the network that it produced based on that. So yeah, I've had to go through this obviously very quickly, and I'm just going to briefly kind of summarize some of the key findings. I think what the study really shows is that different notions of justice, the way that we define fairness, drastically influence network expansion. So you can see three quite different network expansions which were produced there. I think technically we used many different transportation networks, all the transportation networks that exist in Cape Town, but we simplified them down. And this was technically a good solution in terms of reducing computational time. It would have just taken days and days to run the model if we hadn't simplified it. And thirdly, this is a method which is structural and we believe reproducible elsewhere, and we'd like to continue to expand the study. So just to conclude, equity must be a focus in transportation planning. You know, transportation planning is so often designed around profit making, but we need to bring values back into public infrastructure. If public infrastructure can be used for societal good, then equity should be a consideration that is considered and taken into account. Of course, in the real world, this kind of process would have to go alongside intensive sort of stakeholder engagement. There would be other concerns. But what it does do is it makes equity visible. And I think it's another tool in the box in order to bring equity into the negotiations when we're thinking about how we're going to design transportation networks. So yeah, thank you very much. That's the end of my section today. And of course, just to finish, AI, we always have to be critical of AI, of course. There are concerns in terms of limitations, in terms of it being black box, but that's why the stakeholder engagement would be critical alongside this process. Thank you. I'm going to hand over to Josefine now.
Thank you so much, Ruth. What an excellent presentation. It's really an honor following that. Yeah, so warm hello from my side. I'm Josefine. I'm a third-year PhD student or candidate rather at TU Berlin and MCC and Hertie School here in Berlin. And I'm very excited to share some insights from my research today that is looking at the intersection of AI, urban, and climate change. And so just coming from the perspective that we do live in an urban age where a lot of cities are figuring out how can we make the future livable for everyone on this planet in the current state, right? Where, for instance, we have to tackle the climate crisis to enable a livable and thriving future. At the same time, it's a moment where we have digital tools at a scalable level, and we have to really figure out what do we want to use that for what kind of purpose, to what end. And so I'm very interested in figuring out how does this space look like where all of these aspects overlap, right? And I want to share with you two perspectives today. One is the research perspective. So I'm going to share some insights from a study that is currently under review from my PhD. So AI for urban climate change mitigation is really a fast-growing area with research that has really grown so much. Looking at some of the growth rates, I just want you to focus, for instance, on the percentages here that we see, like compared to normal publications in urban climate change mitigation, studies that include ML have grown much, much more. Also, if we compare it from like 10 years ago, really just a few studies in this field to now, like it's really amazing to see that as a researcher to be able to work with such an amount of material. And we were also interested in figuring out, well, how can AI actually be applied in areas that are relevant for urban mitigation? And so here you have an extract from areas that are relevant in the building sector, like looking at the district heating and cooling or operational efficiency of buildings. We match that with the amount of studies we found, as well as the mitigation potential as it is assessed by the IPCC report. And what we find, for instance, is that there are areas that are associated with high mitigation potential, such as district heating and cooling networks, and where we find a lot of research. So that's great. That's promising for this field, right? On the other hand, there are also areas where we have a high mitigation potential, but not that many studies yet. Such as technology to help the uptake of new efficient buildings and the practices around it. And of course, we can now ask ourselves, why is that? How come? And we're, for instance, discussing, and I want to look deeper into that, of how a geographic bias also in the research community is contributing to that. For instance, a lot of the research is focused on cities that are already built up, that are actually prioritizing retrofit, for instance. As you can see here as well, we find slightly more studies in that area. So we have to also be really wary of how a geographic bias or like the priorities from cities, for instance, in the global north that are already fully urbanized might bias the research community to prioritize certain areas versus others. So yeah, I think that that's very important to keep in mind and to look towards how can we practice more of a balanced research, taking into account the needs of all cities and be open to problems that might be not just relevant to the cities that have a lot of the capacity and a lot of the data. So to just stick with the geographic bias a little while longer, we found research in over 325 cities in over 76 countries. This gives you an idea with the black dots of which cities we found research. And the size of the dot does show you the amount of studies, roughly. So you see here as well, we have a clear bias in the, or like a clear trend in the like North American region, as well as East Asian region and Europe. Also, I found a lot, like some research, at least in Iran and India. Other than that, like most of the studies, they're just focused on like one city here and there, but it's really not a balanced research landscape. I think it's very important to notice. So let's do the switch from the research perspective where machine learning has become a relevant approach just in terms of what the amount of research we saw and the type of studies that are done match to what matters for climate change mitigation, and ask, what does that look like in practice, right? Is there actually anything happening on the ground? And I'm gonna give you a little spoiler. There, it's actually early days. So based on my research, focusing actually on the European context, looking for good practices, examples that cities themselves have implemented using AI to tackle the climate crisis, I didn't find that much, right? And if anything, it's more about pilot project, testing things. So here comes the deployment perspective. And I'm interested in understanding, well, what is the role of the city administration? And where in these projects is the AI expertise situated, as well as, well, what are some of the key challenges here? Starting with the role, there are cities that are very proactive, such as Amsterdam. I'm gonna give you an example from that in a second. Others are active, like they're interested, they're engaging in forms of co-creation, but maybe not developing AI themselves. And others are more passive. They're interested, they're looking what other cities are doing, but not actively driving AI development. And I also found that the AI expertise is often or rarely actually situated in a team of the city. It's more about working together with the private sector where the development might be happening, or also the city's innovation lab is actually a very interesting actor in this space, and also individual consultants that come in here and there and help guide the city through these projects. And of course, like there are many challenges when it comes to this space, such as building enough AI literacy. Whilst maybe the development can be outsourced, cities still have to build capacity and knowledge around AI, just in terms of knowing how it can actually be used and not just following of the dream of what AI can be, but actually knowing quite technical details, knowing how to coordinate an AI project. And it's also about the maintenance of an AI system. So it might be possible to just procure, to have a contract of an AI, of a system that includes an AI model, but it's also figuring out, well, what do we do with this long term, right? If we really want to use it in the years to come, and having the right digital infrastructure for that. And the last two challenges that I wanted to highlight is, well, obviously, I think that's not a surprise. It's the lack of ML-ready data, right? Like how to address the data gaps. And also figuring out what are the costs and the benefits, and is it like, how do we calculate that even? And with cost, I don't just mean the financial cost, I also mean the environmental cost, for instance, of AI's own footprint, and how do we calculate that versus the impact that it could have for mitigation. Okay, I'm gonna briefly show you an example. Again, I think we're quite focused on the Dutch perspective today. Oh, I forgot one of the most important messages, sorry about that. Sometimes AI is also not required, and that is okay, right? So I think in deployment at the moment, there's a lot of interest in, yes, I want to do something with AI. Let's also do something with AI. That sounds great. But what is actually needed is to take a step back and be also mindful of, we actually don't need AI for everything, right? But we need that capacity, we need that literacy in order to determine that, in order to make informed choices. Okay, now we're going to the example. So I thought I'll talk to you about this one because it speaks to a challenge that is really important for many cities, which is to reduce energy use of their own publicly owned buildings. So here, the city of Amsterdam was interested in figuring out a solution that could help them reduce their emissions, also to reduce their costs, which is a very important priority for many cities, right? But also to help them continue to shape some sort of innovation in the market. So they said yes to an opportunity for a pilot project where the goal was to improve the operational efficiency of the heating, ventilation, and air conditioning system. This received funding from the EU and was just focused on the development of the prototype and testing, right? So this wasn't a large-scale deployment, which is also, again, important to know. The city co-created this together with a startup company. And I just want to tell you where the AI comes in, because of course there are many other variables here. But they use strategic control algorithms that were really compatible with the existing infrastructure, which was very important to this city. And you'll be happy to hear that they were able to also calculate and show that they achieved a 20% energy savings, and overall showed how the addition of machine learning here helped them to more optimally control their energy management, and had some ideas of how to bring that to scale from some buildings to the district level. Just to wrap it off, I have 4 short recommendations. So we are at a point where it's very important to not just focus on what's happening in research, but to evaluate the practical demand, to bring in the perspectives of urban designers, policymakers, the system operators. What do they think they need in order to do a better job and reach the climate targets of the city? We need to do more studies or research around the context of deployment. So not just the engineering side of things, but to figure out the governance of this, the forms of collaboration, and the type of expertise that is needed. Also, we have to use all of these projects as a means to close data scarcity gaps, and to also share data openly, and case studies from many other cities to avoid this geographic bias trap. And finally, to figure out how exactly we can better monitor and also report the greenhouse gas emission reductions that are achieved through machine learning. So yes, as a final takeaway, based on my research, I see a lot of opportunities for in a future of AI to use it towards low carbon urban development. Still, there's a lot to figure out, not just the technicalities, but actually the for whom, for what, and does it actually work? Thank you so much. Here's also my contact details, so feel free to connect and reach out. And I hand back to you, Hubert.
Thank you. Thanks a lot, really, Josefine, Tanya, Ruth, for those fascinating, enlightening, very complimentary presentations. It's now actually time for Q&A session. So if any of you want to ask a specific question to one of the panelists or to all panelists, feel free to use the chat. And like this, I will use it. Just before, maybe I will use my privilege of host to ask you a question. So you all presented different case study, different use of AI for sustainable cities. And it's actually, this question is actually echoing your latest observations, your latest remarks, Josefine. Like from your point of view, what are the main obstacles for, let's say, an urban planner, a municipality, or more broadly urban stakeholders to use AI for what you presented? Like, what would you recommend if people today in the chat want to use, in the audience, want to use AI for those case studies you presented?
Yeah, I think there's actually, there could be various obstacles. I think it does depend on the context, but one that I come across again and again is really quite basic, that we don't know what it can do for us. Like, how can we use ML? Like, what can it actually add? And I think for that, talking to people in the city who are maybe more knowledgeable about what AI can do, but maybe not so much about the sustainable development happening in the city, like to form collaborations within the city to have conversations and to figure out potential use cases. I think that's actually a really good start. Yeah.
Tanya, Ruth, thanks for Josefine. Tanya, Ruth, do you want to add anything?
I would say a big challenge is what we call ground truth data. We say that a lot in AI, which is, ground truth means the data that you're using to train the model. So let's say, I don't know, if you have a model that can look at a street and be able to quantify how many trees there are in that street, you need to feed it data sets where you have a photo with 5 trees, and then you give the answer, like, here are 5 trees in this photo, and then you do a photo with 10 trees, and here are 10 trees, right? And you need to feed all this information to a model, and then so that's what we mean by ground truth data. So for example, with like the B++ project, we fed like 2 million images of insects, each labeled with the insect name, right? So that's the main challenge, is ground truth data. So the reason why I mentioned this is because I joined this lab as a circular economy researcher. I spent 6 months trying to find a way to combine circular economy and AI, and I was not able to do this because of the lack of ground truth data. It's really difficult to, in some topics, for example, in circular economy, when you're looking at materials, there's just not good enough data to train a model that can say, like, quantify the amount of materials there are in a building or something like that. So that's I would say is a big challenge. As we all say, like, we've probably heard this all, like, I think garbage in, garbage out, right? So you need to have very good ground truth data, and only certain use cases would be applicable.
Thanks for that, Tanya. Ruth, do you want to share also your remarks or observations on this?
Yeah, can you repeat the question again? Sorry. Okay.
For you, what are the obstacles of AI adoption by urban stakeholders?
Yeah, I mean, I think one of the biggest obstacles by stakeholders is the fact that AI, there's a lot of terminology around it. It's also, I think, black box. So sometimes it produces results which, are difficult to explain because things are happening in the background. So I think that might be one of the biggest challenges actually with AI and stakeholders, is actually explaining why the model, sometimes it's quite obvious. Like, I think in our study, it was quite clear what the model had done. But particularly maybe when you're trying to optimize or work towards multiple objectives, it can be difficult. And I think this is an issue, and trust by stakeholders in terms of the outputs of the model. Yeah.
So trust and transparency also on algorithms. We have a question from Chris in the chat for you, Tanya, who is asking, could you compare the benefits and challenges of applying computer vision towards tree and vegetation coverage between surface level imagery via satellite or aerial imagery?
Yeah, so basically, what's the benefits of using Street View versus using satellite? I'll talk about trees because we haven't done much work on vegetation. We have done both. Sometimes so currently what we're doing, when I say we, I don't mean we, I mean my colleagues are doing, is they're combining Street View imagery with satellite imagery to kind of confirm tree locations. So there are some things that you can see with trees you can see better with trees from the Street View. So for example, the height or specific location of the trunk. We were also trying to look at something called leaf area index, which is basically how dense the leaves are. So this would show like how much sunlight could penetrate the tree, and then it would show how warm the street could be in the summer based on how much shade the tree is casting. So, so I would say there are some information that can be better found through Street View data that can't be found from satellite data. And another thing is, but the trade-off is coverage, because Street View is not covered, has not got global coverage, but then satellite images have more coverage. So that would be the trade-off. And I also saw that there was a follow-up question about vehicle detection for emissions estimation between video sources which are stationary versus in motion. Yeah. Honestly, I don't think I can answer that question. So if you want to send me an email and I can forward you to people who can answer.
Thanks, Tanya. And it's also interesting because it's echoing actually Josefine observation on the need of having like different trade-off depending on different parameters. So I guess it also basically depends on stakeholder, the resources, the priority. So really different also elements on it. And we have a question from Irena who is asking to Ruth, which model did you use for your equity study?
Yeah, sure. So my students did the implementation, but we used a Q-learning approach, which is a reinforcement learning algorithm. Essentially, as I said previously, it helps an agent, an AI agent, to basically learn. It learns through making decisions, right? And it tries to maximize a reward over time. So there are penalties and rewards for each decision it makes, and eventually it learns from these decisions to lead to an output, which a final output which it generates, which in this case were locations for stations, for new stations, in order to maximize accessibility according to a specific sort of social justice framework.
Thanks so that's Ruth. We have a question from Ursula for you, Tanya. Do you think there is now computational capacity to determine tree allometry using Google Street Maps?
Yeah, I mean, so this is something that my colleagues are working on. As I understand, it's like the tree allometry is kind of like the dimensions of the trees. So we kind of are trying to do that. So so what I showed you with Treepedia is a very old project. So there we were just using images and then counting literally how many green pixels were in that image. But now we're trying to specifically understand the characteristics of the tree. So the height, the like where the leaves are, and then what we're most interested in right now is leaf area index, because that affects the shade the most, because it's also just what we're interested in. So we're more interested in shade right now, shading in cities to prevent urban heat. And so that's why we're kind of looking at leaf area index. Not exactly tree allometry, but then kind of still talking about characteristics of trees and trying to also find the species, the height, things like that.
Thanks a lot, Tanya.
Sorry, one thing. Sorry. Like again, that's the problem of ground truth data, right? So it's kind of hard to, there's like, look, there's two ways of doing it, right? So with computer vision, there's the thing where you train a model with a bunch of images and labels. So for example, tree species would be like that, right? You give a model like 1 billion photos of 1 billion trees, and then you say this tree is an oak tree, et cetera, et cetera. But then another way is to literally analyze the image itself, right? That doesn't require training. I mean, that is also trained, but you don't need like the ground truth data. You can, for example, literally count how many green pixels there are in an image, or how many leaves there are in an image, right? These things don't require ground truth data. So actually those are quite interesting, because then you don't need to train a model, right? So that's for me, I think like the more interesting direction in terms of visual AI and cities.
Thanks a lot, Tanya. And I actually put in the chat a link to a previous conversation we had 2 years ago with Anthony and Sarah Berry for season 1 of The Future of Urban AI about the quantified canopy. And she was also elaborating on similar topics. So really feel free to to go on this article. We have a question from Adeline, and this one is maybe, I guess, for all panelists. So to you, Josefine, Tanya, and Ruth, who is basically, I think, elaborating on your answer, Tanya, when you were explaining that we basically need more data, better data to fuel AI. And based on this, she's wondering if at the end of the day, the government would have most data, and so there would be the organization that would mainly use AI, or that would mainly be state-related projects. So yeah, do you see that some organizations, because they have more power, more data, can be more adapted to use artificial intelligence?
I think it depends on who's doing the research, right? Hello, Adeline, by the way. She's my friend. I didn't know she was going to join. So for example, like a lot of the projects that we're doing with Amsterdam, the whole idea is Amsterdam has really good data, and then we will use the good data of Amsterdam to train a model that can be used everywhere else. So for example, tree species, right? So like for example, Amsterdam has a very detailed map of tree species, and then we have street view image of those trees, and then we can recognize the trees, and then we can apply that model to many other cities in the world. So I think it depends on the ownership of the model, right? So if academics do it, then you can publish it as open source, and the model can be used by anyone. Then it's funded by the government most likely, but then it's for everyone. And you know, for example, the B++ project, the one where we were recognizing insect species. So there were other models that could already have similar performance, but they were private. So you had to pay for it. It also came with a sensor, and you'd have to buy the sensor, and then the model came with the sensor. And so what the team just did was like, well, this should be free. So we did it. And so now it's an open model that anyone can use. So yeah, it depends on the ownership and who's doing the research, I would say.
Can I add?
Like to, yeah.
Okay, you go first, Josephine, and then I'll add.
Sure. Yeah, I think this is actually a very important point that also touches upon a lot of data governance questions in the field. So, and when it comes to public sector, I think many cities are very much invested in having their own data and to create an infrastructure where they can really maintain data sets well and share them, or find good governance solutions, how they can work well together with companies like big tech companies who also have a lot of the data, maybe more granularity than they could ever host themselves. At the same time, I think having, I mean, you were able, as you just said, Tanya, to make that project open and to make it freely available, but I think that's not always the case. I think one has to be quite wary about the conditions around a project and an application and the type of dependencies that are being created through that. And it's a bit of this question always, okay, do we go for like coverage, or do we go for maybe less coverage, but it's open data that we can use and we'll be able to share publicly? And I think this touches upon this challenge that I mentioned as well in my presentation, this having this literacy, not just about AI, but about the wider implications of certain constellations, or having capacity to even evaluate different types of collaborations and how to build your own expertise as a city administration, yet being confronted with the real challenge of not having the financial resources that can offer similar contracts as a big tech company could to data scientists, etc. So we're at a real turning point, or like where public sector needs to urgently upskill their digital capacity. But the question of how to do that is really a big one and unanswered to a large extent. I'll
just add to that. Yeah, I think you've covered a lot, both of you. just coming more from the African context, I can definitely say that private companies definitely rule when it comes to data in that context. And I mean, I think data now is sort of like liquid gold. It's the new currency, and there's a lot of power that also comes with data. And there's a lot of money that behind data too, and a lot of money to be made. And just having done quite a bit of work across Africa, understanding the African context, you know, private companies like Google, for example, will often have much more data on citizens than a government will, because the government will just not have the infrastructure, the resources, the capacity, the skills that are needed to really house and have all the data. So yeah, that's just one perspective I wanted to offer. Another one.
Thanks a lot, Ruth, Josefine, and Tanya, for your answers. Maybe the last question, we have others, but that would be maybe the last of this webinar, from Dan Torres, who is asking, sometimes we do not have all data for a specific study. What do you think about the usage of synthetic data from simulators to study urban solutions? Ruth, we did a report on generative AI. Do you want to answer?
Sure. No, I think synthetic data is great. I think with generative AI now, there's lots of opportunity to have synthetic data. I mean, I've even tried it out myself. I've uploaded, you know, an Excel with a data structure and asked ChatGPT to, you know, create something that's similar. And I think there's lots of opportunity there for generating data sets which you know, are similar to the real thing. And it's also great for privacy, right? Because you know, you have the synthetic data which maybe isn't linked to specific people. I think there are lots of opportunities there. I don't know if anyone else wants to add anything.
Yeah, I want to add something, because when I joined this lab, I had 1 million arguments with people in the lab about this. So for some context, like the lab that I'm in is very allergic to synthetic data and models, right? They want to know, like, I want ground truth data. And the thing is, when you're just using real ground truth data, you can't predict the future. That's the thing. But then when you do sustainability, you have to predict the future, because there's two halves of sustainability. There's climate adaptation and climate mitigation. Climate adaptation, you can look at how the world is today and adapt to it today. Fine, you can use ground truth data. But climate mitigation is, how can we minimize emissions and environmental impact in the future? So you have to use simulated data or some kind of modeling that predicts the future. So in my opinion, yes, it is very important, but not everyone agrees with me.
Thanks a lot. I think we are good then. We are almost out of time. Thanks a lot, really, Josefine, Tanya, Ruth, for this fascinating session. Very enlightening, both with presenting research, academics project, but also very practical recommendations. So it was really a fascinating episode. Next week, we will welcome Archetype AI to talk about physical AI, so how generative AI can be used to talk to data, basically. So you will see how we can do this. Anthony Thompson will be the moderator of this session, and this episode will be available in the very coming days in Urban AI YouTube channel. Thanks for attending and take care. Bye.
Bye.